Okay, so this begins our discussion on ampacity, and I thought I'd put this on a video so that you could refer back to it when you need to. But it's a very simple concept that an ampacity of a conductor is the maximum current in amperes that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Now, through example or through table 310.15b16 is your ampacity tables. And I discussed these in class, but you could find the ampacities of certain conductors, the sizes of conductors here, and under different temperature and their different temperature limitations. So these ampacities on the table are based on two things and two things only. They're based on 3 conductors in a raceway and at an ambient temperature of 86 degrees Fahrenheit. So I have here, anytime that you're given a question that is outside these parameters, the conductor's ampacity must be derated according to the factors from the following tables. And if it's a table that, if it's a parameter that involves the number of conductors, that is on table 310.15b3. If the parameter is discussing temperature, then you'd find that on 310.15b2b. So I've got down 3 examples here that I'd like you to take a look at, and we'll just bring this back to its original picture. The first example is what is the ampacity of 3 number 12 TW conductors in an ambient temperature of 86 degrees. Okay, so that you notice first off that the question asks a question that's within these parameters. If you read the table topic or the table heading, you'll find that these ampacities agree with 3 current carrying conductors in a raceway and at an ambient temperature of 86 degrees. So there's no derating that is necessary here. And you would simply use the column of number 12, size number 12 conductor at a 60 degree temperature rating, and you'll get looks like 20 amps. So the answer to the first question is 20 amps. Now the answer to the second question. What is the ampacity of 4 number 12 THHN conductors in a raceway? Okay, so now that we're talking about THHN conductors, that's in the 90 degree column, and we find that the starting ampacity is 30 amps. And we need to multiply that ampacity by a correction factor. And that correction factor, since it's above 4, it's outside the parameters of this table, we need to go to this table, and that is table 310.15b3a, and you find the number of conductors, and you see that the percent in value, you see that the correction factor is 80%. These are percentages here. and these are the number of conductors in the raceway. So you would take 30 amps and multiply it by the percentage, which is in this case 80% or 0.8. So you'd take your calculator and you multiply that by 0.8, and that gives you 24 amps. That's the new ampacity, so that none of those 4 conductors in this raceway can go above 24 amps. The same thing is done when you're having to when you have a temperature element in the question. The question 3 states, what is the ampacity of 9 number 12 THHN conductors in a raceway in an ambient temperature of 105 degrees Fahrenheit? So again, you would start with 30 amps, because 30 amps is from this table here, from your ampacity table, number 12, and you're talking about a THHN conductor, and that gives you 30 amps. So to the number of conductors in the raceway, 7 to 9, you're asked to take 70%. So we're going to put 0.7% here. And the next correction factor to adjust for is the temperature. So we go to the temperature correction factors on this page, and we find at 105 degrees Fahrenheit, in the 90-degree column, you have a 0.95 factor. 0.95. You multiply those figures out, and you should get 30 amps times 0.7 times 0.95, and you get about 19.95. 19.95 amps. And that's the ampacity, your newly derated ampacity of these conductors. Of any of those 9 conductors cannot go past 19.95 amps. And that's how you figure ampacity derating.